So good morning, everybody. So I am Mahdi Madani from the University de Bourgogne in Dijon, France. And today I present for you my work entitled Visually Image Encryption based on efficient deep learning autoencoder. The outline start by a small presentation of the context of this work. After that, I speak about the general CNN-based models. Then I pass to specify the use of a CNN-based model for data protection in general. And after that, I present the proposed autoencoder in the CNN-based mode. And I present some experimental results before concluding this presentation, and I give some perspectives in the future. So, as we know, all today we have a lot of personal data that are transmitted and received and saved over the different digital communication, wireless network, cloud servers, object connected. So all this cyber world, we used people on personal data. So these data are vulnerable and permanent. So since a lot of decade of years, this problem was how to protect the personal data or the digital data, or also we need to protect some devices from passive and active attacks. So this is the challenge since a lot of years, and the used solution or the standard solution are the standard cryptography. We are using block ciphers or stream ciphers like IS, DS, SR algorithms in all the used networks. This to ensure the confidentiality or the encryption of data. They are also the use of cow-based systems like Lorentz system, logistic maps, a chain system. They are generally used like a generator network or random generator network to generate a secret key and key streams. There is also the use of hash function to ensure especially the integrity of some sensitive messages. The principle is to generate a message authentication code to combine with the message before sending it, and the receiver can ensure that the message is not altered during the transmission by active or passive attack. And maybe in the future, we have new quantum cryptography techniques. But in this work, we speak about the problem or the attacks are using the artificial and intelligence techniques. So here I give some attacks that are using deep learning attacks. For example, the deep learning based attack on market IS. This is an attack on an encryption algorithm. We have also breaking cryptographic algorithms using deep learning techniques, and unsupervised cipher cracking using the GANs. So we remark that there is a lot of attacks that are based on the AI techniques to access the data. So the proposed solution to resist the attacks, we started in the last decade by using some dynamic S boxes. They are generally used in the block ciphers. So like the IS, for example, to enhance the security in permanent. And when we change the key, we have sometimes the S box. And also there is a new generation of encryption algorithm based on AI models. So before presenting the security using AI models, I start by general use of CNN-based models. They are based net or neural model consists of three main layers. The input layer that we can start by the data. It gives, for example, for us, we use the images. So each pixel will be considered that the input to the neuron, and the hidden layer, we take this input data and will be used, it will be multiplied with the learnable weights and added to a learnable basis to generate the hidden layer. And this layer will be followed generally by activation function to add some nonlinearity to the data. And the last layer of the neural networks is the output layer, from which we can use a logistic function. For example, the most used one, the sigmoid or softmax, which convert the output of each class into probability or score, and the high score will be considered that the expected output of this data. And to obtain the best performance, the model calculates the error. So in the training phase, in the feed-forward propagation, and the derivative to minimize the loss in the back propagation direction. So this is the main format of neural network. So they are generally used in image processing problems like object detection, people recognition, segmentations, and recently these models are used also for cryptographic algorithms to ensure the best security of our digital data. So the CNN, like the others used for computer vision, are also trained using data that can be the text, dataset, image, audio signals, and maybe other parameters. So they are based on the same layers. So input layer, it is the image, RGB image, for example, of a fixed size, height, and weight. And the convolution layer, we use filters to transform the image to a multi-channel image of small size. And for this, we use the dot product between the kernel weight and the learnable filters, and the patch from the input data. And we have also to use the activation function to add non-linearity to our network. The most used one, the ReLU or tangent, the hyperbolic, for example. And we use the pooling layer is inserted generally to reduce the volume size and make some computation fast. So we need to reduce, for example, the size of data. The most used one are the max pooling and the average pooling. And before output, we use the fully connected layer to compute the classification or the regression task from the previous layer. And the output one is the fully connected layer is fed into the logistic function like sigmoid or softmax to convert the output to probability score of these classes. For example, here we have just to summarize example from the input to the output. So we have the input is the image of the car, and we have multi-layer convolution and ReLU convolution and ReLU and pooling. So to reduce and extract some features. And the last one is the fully connected layer. We have the score of the expected data. We remark that the high score is for the car, so the expected data is the car. So is the best, for example, the best response for this global example. So now we speak about the CNN-based model, but that are used for data protection. So generally, the protection of data in the digital form can be audio communication or video communication, digital images, our ID, and our social security number that can be a lot of personal data. In this work, we speak only about the image or digital images. So all this data need to be encrypted from the user, but also in the other side of the network, the receiver need to decrypt the data. So for this kind, we have two main techniques. We have the symmetric encryption or asymmetric encryption. In this work, we used only the symmetric mode, so we has to use CNN-based model, but in the symmetric encryption mode. But what is the symmetric mode? Quickly, the symmetric encryption mode is established between two persons not connected in the same place. We have transmitter and the receiver. So the transmitter has the plain data, for example, a plain images, and he used an encryption algorithm, maybe IS, maybe another algorithm, maybe chaotic generator. So this algorithm, we can call it K-stream generator. It is based in secret key and the initialization vector. They are the two main input to the algorithms, and this algorithm generates a stream cipher that will be combined generally using only a bitwise XOR operation with the input image pixel by pixel, and we have in the output an encrypted image. So this image is transmitted in the encrypted or in the secure format, and the reception, we use the same technique because we have symmetric, so we need to use the same algorithm with the same input. So the same secret key and the same initialization vector. And if we use these three main information, same algorithm, same secret key, same IV, we generate the same key stream to decrypt the image using the same operation, bitwise XOR operation. So this is a generic symmetric encryption mode. For example, we can apply this mode in a real application. For example, here we have an example of a user that are using his connected object, can be phone, tablet, or his camera, have digital data that will be encrypted using an encryption mode or encryption network here. And you have the encrypted data can be saved or can be transmitted over the network, and the user or the same user or another person can access to the data if he has the possibility to decrypt the algorithm or to decrypt the data using the same trained model, for example, in picture. So here I present just quickly some attacks, some models that I used to encrypt data. For example, we have a deep learning based stream cipher generator is used for medical encryption images, medical encryption and decryption. This work is based on the use of the GANs to generate private keys, and we can use image transformation network for generally visually protection image to generate new encrypted image using without using input case, and learnable image encryption. So we remark that the presented example are based on using deep learning or AI models to encrypt or to protect the security of digital data. So now we speak about the proposed model. So it is proposed to respond to the same challenge, so to propose new solution or new challenge to improve the security of digital images using CNN or deep learning based model. So this model is based on using the convolution or CNN models to implement an autoencoder for image encryption and decryption to reconstruct the plain image. And the results are correct. And this model can be used for encryption and also for some application of completion, because the encrypted image is reduced, the size of the image is reduced. So the design is based on using filters. So CNN model, we use the filters to detect some features from the input image, like the edge shape, color from the original, and other features. And this model is trained in the back propagation to learn how to minimize and how to adapt the weights and the base to approach the original and expected images. This is the first step. And the second step, it is trained to allow how to learn complex patterns from the plain text image to generate an acceptable ciphertext. Because this ciphertext will be used later or at the second or the other side of the network to reconstruct the plain text from these parameters. So we have the second step. We trained the model to decrypt the image. We have the input will be the encrypted image, and it will be trained how to reconstruct the plain data without a lot of losing the data. So acceptable input image. So this is the global autoencoder presented in this work. So the first step or the first phase is known the autoencoder to encrypt and the decoder to reconstruct or to decrypt the image. So the encryption or the autoencoder in the first phase used, as we say, the convolution filters and the ReLU activation function to add some nonlinearity. We used this with a pooling layer. So we use the max pooling layer to reduce the model or these layers for 2 times. So we passed from the image of size 32 times 32 to an encrypted of 8 times 8 with multi-channel to 64. We passed from 3 RGB channel to 64 channels. So the final one is the fully connected layer. So we extract the features of the input image and we generate or we produce the cipher image. Here we present one channel of the encrypted image. So this is the first phase of the autoencoder. This is the encryption phase or the encoder phase. The second one, we trained the model to decrypt. So this is the decryption process. It is based on implementing the same network layers because it will be used in the symmetric mode as we specified before. So we need to use the same model, but we applied the operation or the layers in the reverse orders. And to reconvert the data from the reduced size 8 by 8 and discover 32 times 32, we use the convolution transpose function. And this technique allows us to reconstruct the input image using the trained model. So this is the decoder phase. So as we can remark, the two models are working in parallel. So in parallel or in the two sides of the network. For example, the emitter use the coder and the receptor use the decoder. So, but we have the same trained model. So the encoder and the decoder, the second phase of the network. So this is the trained autoencoder, and to experiment or to test this model, we used existing dataset. We used the CIFAR dataset that contains 60,000 color images divided into 10 classes. So we have 6,000 in each class. And for the training and test, we have 20% to test and 80% of image to train the model. And during the training step, the autoencoder is trained in two directions: to learn how to encrypt in the first step, so to encrypt and use the important information of the image, and in the second step, it is trained to reconstruct the plain image. So we minimize the difference between the input image and the expected decrypted image. We fixed the learning rate to 0.001. So the recovered image will be an approximation of the original image with some lost in some pixels. Here we present some visually data. This is an example of the original images. After encryption, we have the encrypted image, and after decryption or after decoding, we have a encrypted image. We remark that the decrypted image is smally noisy compared to the original one. This is the limitation of the proposed model. So we applied for other images, or the second and third image, you have the same problem. We have some limitation in the decryption process of the autoencoder. So finally, we remark that the encrypted image is visually protected, so we can not remark easily the input data. This is the first advantage, and we have a reduced dimension of the size of the image. And the limitation is the recovered image after the decode files are noisy, but we can recognize, so it is not totally false. We can recognize the input data, but it is noisy. So if we can consider the encryption model is acceptable, so we can use it for encryption problems. It can also use it for compression or image reduction applications. So to conclude, in this work, we conducted a comprehensive analysis in visual image protection techniques, and we used a CNN-based model. And to train and test our model, we used the CIFAR data set. And the implemented CNN is based on an autoencoder, and it is trained in two phases: encoding the image and decoding to reconstruct or recover the plain image. And the experimental results show exhibit proficient decryption and acceptable decryption process. So this is the first version of this model. It is promising for image protection and decompression, but it still requires some improvement. So in our future works, we aim to address this limitation of the decryption files using more deep architecture. We check to use more than two levels of the convolution and max pooling and layers. And the second improvement of this work may be to explore the implementation in hardware environment, for example, using FPGA system to evaluate the real performance of this model evaluate this frequency and test its suitability for real-time application, and we evaluate also the hardware required resources, the memory required, and all the hardware requirements. This is all for me. Thank you for your attention. And if you have questions.